Hi there everyone. Today we'll be solving mathematics paper 1 pure mathematics, which is also called P1. This will be done according to the syllabus for 2024 and onwards. So therefore if there are any questions which are not part of the syllabus now from 2024 onwards, these questions will be omitted. But of course, solving from all past papers will give you a good idea of how you'll face questions in the future exams. So today we'll be solving May June 2018 variant 1 1. Right, let's move on to the first question. Find the first three terms in the expansion in ascending powers of x, 1 minus 2x. So we can write 1 minus 2x whole power 5. And let's write in the way you have written the binomial theorem. This follows the binomial theorem, and usually you'll see the answers in this form where you're writing 5o and then the coefficients and so on. We know that for the first term we won't be having any x coefficient because it will be x power 0. In binomial theorem, the powers increase as you go from left to right, which in this case x power 0 will be understood 1. And after this we'll go for the second term, which will be 5 1. If you're wondering what this means, this is the notation used for writing the coefficients. 5 1 basically means 5CR. This is a function which you can also find in your calculators, and this helps you in finding the coefficients that are with each of the terms in the expansion. So we'll have after the second one 5 1 followed with 1 raised to the power 4. So the way the pattern goes on is like this. First of all, we have 5 and multiplied with 1 raised to power 4 and minus 2x raised to the power 1. So you can understand by now how the pattern goes. When we are moving from left to right, we'll start with the 1 power, and it will be starting from the highest value 1 raised to power 5. Again, it's understood. We could have written here 1 as well, but of course it will be multiplied, so it should be understood. 1 power 5. For the first term we'll be having 1 power 5, and whatever is the second term, which was in this case minus 2x, that will have power 0. And then when will you move on, the first term's power is going to decrease while the second term's power is going to increase. Similarly, when we'll go to the third term in the expansion, the first term's power is again going to decrease and the second term's power is going to increase, which will be 3 in this case. Now of course you could also do it the other way. You could start by using the second term first and use the first term as a second term. You could regard it in any ways. So following this pattern, we have 5 0 plus 5 1 multiplied with the first term 1 4 and minus 2x raised to power 1, just for the sake of understanding. And after this we'll have another term 5 2 1. No need to write the power, it is 3 by the way, minus 2x raised to power 2. Now you may be wondering why I am not going any further than this, because they have said to us to find the first three terms in ascending powers of x. First three terms are just this much, which will be 1 and not plus but minus 10x. You can get the value of this 5 1 by clicking the button in your calculator, which will look something like this, NCR. When you'll put this in your calculator, you're going to see a letter C in your calculator. On the left side of it, you're going to write whatever power is present on the expansion. On the right side, you're going to write for which term you're trying to find. The first term, which is of course the 0, or the second term 1, and so on. So if we'll give this 5C1, it will give you 5. And that 5 is multiplied with minus 2, you get minus 10x. So minus 10x is the second term, and then we have plus 40x square as the third term. And you can see that we have found the first three terms in ascending powers of x. You do need to know that this is also in ascending power of x, just that it is x raised to power 0, which is 1. Most of the students would go for a third term and they would completely ignore the 1. And so this is your final answer. Moving on to the next question, they have said to us, given that the coefficient of x square in the expansion of 1 plus ax plus 2x square multiplied with 1 minus 2x whole power 5 is 12. Find the value of the constant a. Right, so we know that coefficient of x square is 12 for this expansion. So we can try making an equation out of this where we have 12x square. We're going to equate it to whatever terms we can multiply and get the power of x square. So let us start one by one. We have already calculated the first three terms. So all we need to do is to just multiply them together and write only those terms which multiply to give x square. So let's start with 1. 1 is same. 1 with minus 10x multiplied does not give us x square, and then 1 multiplied with 40x square does give us the x square coefficient. So we are going to write over here 40x square plus we're going to write our other terms. Let's go for now the second term. So basically what we're doing in this question is that we're only considering the first three terms, because beyond that it would be going on to x raised to power 3 and so on, and that is not what we're looking for. We're looking for only till powers of 2. So let's now go with ax and multiply them with the first three terms. Ax with 1 does not give us x square power. Ax with minus 10x gives us the power minus 10x multiplied with ax. So that's our another term which will have x square coefficient, x square base, and then we're going to multiply ax with 40x square and we'll get 40x cube. That's not what we're looking for, so we ignore it. Now we'll go over with 2x square multiplied with 1. That gives us 2x square with the coefficient x square. If we multiply it with minus 10x or 40x, we'll get powers of 3 and 4, so we ignore that. Now we can simplify 40x square minus 10 ax square plus 2x square is equals to 12x square. So basically we have collected all the terms which, when we have multiplied with this whole term outside this expansion, and we got these terms. So the sum of these terms should equal this term over here. So right, so we can cancel out x square after taking common, and then we're left behind with 12 is equals to 40 minus 10a plus 2. So then we get our this final equation, which is 12 is equals to 40 minus 10a plus 2. Now we can solve for a. 12, which is equals to 40. Let's put this on a calculator. Minus 10x plus 2, and we solve it and we get our answer 3. And this question is also complete. Next question. A point is moving along the curve y equals to 2x plus 5 over x in such a way that x coordinate is increasing at a constant rate of 0.02 units per second. Find the rate of change of y when x is equals to 1. The first thing you should do whenever you see an overwhelming question is that you should note down all of the information you have. Right, so what do we have over here? Dy over dt, which we have said is rate of change of y over t time. We do not know, but we have to find it. What we are given is rate of change of x, which is represented as dx over dt. That is 0.02. And the question asks us to find this value. So what we should do is that we should find a way to relate these and these values. So using the differentiation chain rule, we know that dy over dt is equals to dy over dx over dt, dy over dx multiply with dx over dt should equal dy over dt. Now how did we figure out that dy over dx should come over here? Well, according to chain rule, we should have multiplied something with dx over dt in order to get dy over dt. From this, it looks obvious that we need to remove or cancel out the x in one way or another and keep the dt as it is. We have another term which we can use, that is dy over dx, and that's why we are given the original equation in the first place. So that is why we have multiplied dy over dx over here according to the chain rule. We have multiplied it, and that's what gave us dy over dt. So let's start by finding dy over dx. Let's bring the equation into a more suitable form for differentiating. 2x plus 5x inverse. So we have everything in numerator form, and then we start to differentiate it. We're left behind with 2 and minus 5x raised to the power minus 2. Why minus 2? Because when we are differentiating, we subtract 1 from the power. When we subtracted 1 from the power of 2x, the x was removed. But that's not the case for the x over here, which is already an inverse. Minus 1 and minus 1, that gives us minus 2. So we have got the dy over dx. Now we can go for dy over dt, which is 2 minus 5x inverse square multiplied with dx over dt, which we were given as 0.02. Now we can of course see that we still cannot solve this equation because we don't have the value of x. Well, luckily we are given the value of x for which we are going to find the rate of change. Substituting in the values, we get 0.06, and that is equals to your dy over dt. Your final answer is 0.06. Right. In the next question, a curve is such that dy over dx is equals to 12 over 2x plus 1 whole square. The point 1 lies on the curve. Find the coordinates of the point at which the curve intersects the x-axis. So they're asking us to find the coordinates of the point at which the curve intersects the x-axis. This cannot be done directly from the derivative. So from this, it should be obvious that we should be finding the original equation first. If I denote equation as fx and its derivative as f apostrophe x, to find from the original equation the derivative, we differentiate. But if you're going to find the original equation from the derivative, you're going to integrate. So we're going to integrate our derivative to get the original equation, and then we're going to solve to get the point at which the curve intersects the x-axis. So let's integrate it. 12 2x plus 1 raised to power minus 2, brought everything up, and we're going to differentiate it respect to dx. And according to the chain rule in integration, we have one bracket inside over here and we have an outer terms over here. So for this, the integrand will be 12 2x plus 1 as it is. We add 1 to the power, so minus 2 plus 1, and we do n plus 1. So for every term, whatever term of x we have, we do n plus 1 and divide the term with n plus 1. Over here we had 12 raised to the with its term 2x plus 1, which we had whole inverse now, and n plus 1. N over here refers to this minus 2. We do the minus 2 plus 1. But this is not all of it. We also need to integrate the terms which are inside. If we integrate the terms which are inside, you're going to get 1 by 2. And according to the differentiating chain rule, the same things apply for integration. You multiply whatever integrand you found for 2x plus 1, which is 1 by 2, plus an arbitrary constant, which is always missed by many students because it's always written at the end, but it's an important part of integration. After simplifying this, you will get y is equals to minus 6 2x plus 1 whole inverse plus c. Now we still cannot see the point at which the curve intersects the x-axis, although we have got the original equation because of this c-intercept, which we still don't know. The solution, we have already been given a point. We can substitute the values for the point here. 2x, that's just 1, 1, minus 1 plus c. Solving for c will give us 3. So our original equation in this case becomes y equals to minus 6 whole bracket 2x plus 1 minus 1 plus 3. And now we want to get the point, the coordinates of the point at which the curve intersects the x-axis. At x-axis, the y value is 0. So minus 6, 2x plus 1 inverse plus 3. And then when you will solve for x, you will get 0.5. Therefore, your point will be 0.50, where the curve touches the x-axis. In the next question, we have proving the identity, which should be one of the most simplest questions in the whole of the paper, because you just need to refer to your formula sheet that will be given with the paper. Prove that identity sine theta plus cos theta brackets 1 minus sine theta cos theta is equals to sine whole cube theta plus cos cube theta. So for doing this question, we can refer to the formula sheet. First of all, let us pick a side. You can either start by trying to make this side equal or this side equal. I would pick the second side, but you could have also picked the first left hand side, which could have also been easier. Right. Let us start by simplifying this larger one. So we'll pick the right hand side. We're first of all going to write sine cube theta plus cos cube theta is equals to sine theta plus cos theta brackets and then 1 minus sine theta cos theta. Remember, these two terms are multiplying. Sine theta is multiplying with cos theta. It's an identity. So we're now only going to pick one side and try proving it from there. First of all, we want to remove this 1 because there is no 1 in this expression. The very first thing you should try doing is to remove any other kind of terms which are not on the other side of the equation. You can see 1 is over here, but it's not over here, so we're going to try removing 1 from here. If we refer to the formula sheet which is given with this book, we can see that cos square plus sine square is equals to 1. So we can substitute instead of 1 cos square plus sine square. So when we rewrite this, we will get sine theta plus cos theta cos square theta plus sine square theta, because we replace the 1, minus sine theta and cos theta. And now we open the brackets. Make sure you do this step carefully, because if this step is messed up, you won't be able to equate both of them properly. So after opening the brackets, we will get sine theta multiplied with cos square theta plus sine cube theta minus sine square theta into cos theta plus cos cubed plus cos theta and sine square theta minus sine cos square theta. At this step, you can see that many of the terms are similar. So if we look over here, we have cos theta sine square and sine theta cos theta. Both of them are same and have the opposite signs, so we can cancel these out. Similarly, we have sine theta cos square theta and we have sine theta cos square theta. We can again cancel them out. What we are left behind is sine cube theta plus cos cube theta, which is equal to our left hand side or the right hand side. And thus we have proved this equation. Now in the part 2, they ask us, hence solve the equation sine theta plus cos theta and the rest of the terms is equal to 3 cos cube theta. Remember that this question is related to the previous question. You are not just going to directly open the brackets and solve for this. We have just figured out that this whole long term equals sine cubed theta plus cos cube theta. So this whole term is now equals to this as previously said in the question. And we'll get 3 cos cube theta over here. We bring the cos cube over here on this side, that gives us 2 cos cube theta, and we have sine cube theta. And over here we're going to apply another rule. When we are going to bring sine cube theta over cos cube theta, you're going to notice something, that we have sine over cos. We know that tan theta is equals to sine theta over cos theta, and that is also given in your formula book. So if you're going to whole cube this, similarly tan theta will also be cubed, and over we have the cube form, therefore we'll have over here replaced with tan theta cubed is equals to 2. And now when you will solve for theta, you will get approximately 51.6, and this is not the only angle, because they have said hence solve the equation for theta to be greater than 0 degrees and lesser than 360 degrees. This is just one of the answers. You will have another answer which will be 51.6 plus 180, because we know that the tan graph, the graph for the tangent, always repeats after 180 degrees. So we're going to add 51.6 plus 180 degrees to get our second answer, that is 231.6. Beyond that, the angles will start going out of the given range, and therefore it would be invalid. So these are your two solutions, 51.6 degrees and 231.6 degrees. And now we come to question 5 about coordinate geometry. Coordinate geometry should be one of the easiest topics to cover in this whole paper. So let's see the question. Diagram shows a kite OABC in which AC is the line of symmetry. Coordinates of A and C are 0, 4 and 8, 0 respectively, and O is the origin. So they have said to us this triangle AOC is similar to ABC triangle because AC is the line of symmetry. Find the equations of AC and OB. First of all, let us know the lines that are equal or the distances that are equal. As a general rule of thumb, that's always the best thing to do when you're solving these kind of questions. So we know that AB is equals to AO, because the line of symmetry is over here, AO is on this side and its respective side or the corresponding side is AB. So these both have equal lengths. And we also know now that BC is equals to OC, the distance. Knowing these factors, first of all, now let's find equation of line AC. For AC, it's quite simple because we are given the points already. We are going to use the line of equation of a line, which is y2 minus y1. Let's write it in subscript. Y2 minus y1 over x2 minus x1 is equals to y minus y1 over x minus x1. Putting in the values for point A, which is, and point C, we will have 0 minus 4 and 8 minus 0, that will be equal to y minus 4 and x minus 0. And now we're going to make y the subject to get our line equation, which will be minus 1 by 2x plus 4. This is the equation line for AC. And now we're going to find for OB. So the first thing we need to know is that it will be always be a good practice to sketch the line whenever you're trying to find it. So what we have looked over here, OB and the line AC are at perpendicular angles because these are the diagonals. It is a property of a kite that its diagonals always intersect at right angles. So we could apply the property of perpendicular lines where we have m1 into m2, two gradients that are perpendicular would always have the product of -1. So we need to find first of all the gradient of this line, perpendicular gradient, -1 by 2, and we're wanting to find the gradient which is perpendicular, and that will be the gradient of line OB. We solve for m2 and we get 2. And that is more than enough because we have the gradient and we have the point. The point over here, 0, 0. We can put this into line equation, which is y minus y1 is equals to m x minus x1. Substituting the values, y minus 0 is equals to 2x minus 0. If you simplify it, we get y is equals to 2x. This is for your line OB. And then we find by calculation in part 2 the coordinates of B. So to find the coordinates of B, we are going to do a trick over here. We know that the line of symmetry is AC. So the distance from O to the point where this is intersecting AC is equals to this point to the point B. We're going to call this point as X. So first of all, let us find this point X. And how do we find it? We have the lines AC and we have the lines OB. We are going to simultaneously solve them. Let's write 1 by 2 as 0.5 for clarity. Now we're going to solve this and we get X is equals to 1.6. And if we want to find the Y value, which we have to, we're going to put 1.6 back into one of the equations, either choose this one or this one, really doesn't matter. We'll get 3.2. And we get our point X of intersection as 1.6 and 3.2. Now we can establish the relation that from origin to X, distance is equals to the distance from X to B. We can apply the distance formula over here. 1.6 minus 0 whole square plus 3.2 minus 0 whole square is equals to X minus 1.6. Why we're using X? Because we do not know the point B. X minus 1.6 plus whole square plus Y minus 3.2 whole square. The roots will cancel out and we'll be left behind over here with 12.8, and over here we'll have in the expanded form, or let us directly just simplify it, we will have over here an equation for this that will be X minus 1.6 square plus Y, but we don't need to put Y for this one. We know that OB is a line in which we have the point B. So you would need a second equation for this. In the end, we would still end up simultaneously solving it. But we do know that y is equals to 2x and point B lies on this equation or lies on this line. So we could regard y as 2x as it is still applicable for this line. So you could put square over here, and then when we will solve for x, we will get two values, which is 3.2 and x is equals to 0. All of this will basically form a quadratic, and when you simplify, you'll get x is equals to 3.2 and x is equals to 0. Obviously, x is equals to 0 is not a coordinate which you're looking for, because if you refer back to the original question, b is definitely not on x0. So we got the x value, we can also now get the y value, which we can substitute into the equation of OB 3.2, we get 6.4, and therefore we have point B as 3.2 and 6.4. Now we have a question about radians and sectors. The question asks, the diagram shows a circle with center O and radius R. The points A and B lie on the circle and AT is a tangent in the circle. Angle AOB equals to the radians and OBT is a straight line. Express the area of a shaded region in terms of R and theta. So first of all, we're going to find area of the triangle, and from there we're going to subtract the area of AOB. So we need to know this line AT. We know that AO is equals to R. So how do we find AT? Because to find the area of this triangle, we need to use the base and the height, and we don't know the base. Well, we can establish a relation over here through trigonometry. This is the opposite side, this is the adjacent side, and therefore we can say that tan theta is equals to opposite, that is AT, over adjacent, that is R. And therefore we get AT as tan theta R. Now we can find the area for our triangle, which will be 1 by 2 base into height. 1 by 2 base, that is R, into height, tan theta R. Simplifying this, we get R squared tan theta over 2. Next, we need to find the sector area. And we know the sector area is 1 by 2 R square theta. If you do not know the formula for the area of a sector, you can always refer back to your formula sheet. And over here, you'll find area of a sector as 1 by 2 R square theta, given that theta is in radians. So make sure that your angle which you're working with is in radians. We have the sector area and we have the triangle area. What did we previously mention? To find the shaded area, we're going to subtract the sector's area. So to find shaded area, we simply subtract both of them, and we end up with R squared tan theta over 2 minus R squared theta over 2 as your final answer. On the next question, they say in the case where R is equals to 3 and theta equals to 1 by 2, find the perimeter of the shaded region. Right, so how will we find the perimeter of this region? We need to first of all know what will be the perimeter of this shaded region. So the perimeter of the shaded region is this line AT and this line BT and this sector over here. That is your perimeter of the shaded region. AT we had already figured out was tan theta R. To find BT, we're going to first of all find the whole line OBT, and from there we're going to subtract our R, and that will give us BT. So first of all, let us find AT. AT is 3 tan 1.2. No need to work it out right now because we'll get the answer in decimal and we need to work to exact values. Next, we're going to find the arc length, because that is also part of the perimeter. Arc length will be 1 by the arc length would be the R into theta, which would be 3 into 1.2, that will be 3.6 centimeters. Next, we're going to find the line OBT, and we can find the line OBT in two ways: through Pythagoras theorem or by trigonometry, sine, opposite, or hypotenuse. You could use any method you want. I'll be using trigonometry. Sine 1.2 radians is equals to 3 tan 1.2, which was our opposite line AT, And our hypotenuse is OBT. Solving for OBT gives us 8.2791. From this, we're going to subtract the radius. 8.2791 minus the radius. What was the radius? 3. And we get 5.2791 as our line BT. To find the perimeter now, we just add all the three values. 10, 3 tan 1.2 plus 5.2791 plus 3.6, and we get 16.6 centimeters as our final answer. Now we have come to a vector question. Vector is not part of the syllabus of 2024 and onwards. Therefore, we will skip this question. Now we have come to question 8. A geometric progression has a second term of 12 and a sum to infinity of 54. Find the possible values of the first term of the progression. Again, we have a lot of information. The best thing we can do is to list everything we know. We know that the second term is 12, and we know that the sum to infinity is 54. So we need to now find the first term. We can consider the first term as a. We know this is a geometric progression, therefore the nth term is equals to a r n minus 1. You can refer this from the formula booklet as well. Substituting n for 12, which is the second term, a r 2 minus 1, which simply gives us 12 a r. We can rearrange this for a, and we have 12 over r is equals to a. Now this is just one of the equations. We need a second equation with which we can find simultaneously a and r values. So we know the formula that sum to infinity is equals to a over 1 minus r. Again, you can refer to this formula from the formula booklet. We know sum to infinity is 54. We don't know what is a, and we don't know what is r. So we bring over there 54 into 1 minus r. We'll be left with a on this side, and a was also over here. So we're going to substitute the value for a over here, 12r. And then when you're going to bring over here, you're going to get a quadratic. 54r square minus 54r plus 12 is equals to 0. Or not 12, 54r square minus 54r, we open the brackets and we get 54r square and 54r minus 54r, and when we bring the 12 on that side, we get minus 12 actually is equals to 0. If you now solve this on your calculator, you will get two values of r. Or wait, no, this is not minus 12. Yes, this must be 12 because we brought all the terms on the other side, right? This must be 12. R1 in this case will be 2 by 3 and R2 will be 1 by 3. So we have found now two values of R1. We're going to substitute both of them over here. 12 over 2 by 3, and we're going to solve for A. And we get a over here, 18. Similarly, we're going to solve for the other value of r. 1 by 3 is equals to a, where a is equals to 36. And you got your final answer is a equals to 18 and a equals to 36. Question number 8, part B. The nth term of a progression is p plus qn, where p and q are constants and Sn is the sum of the first n terms. Part 1. Find an expression in terms of p, q and n for sum of n terms. So first of all, we need to identify which kind of sequence is this progression. This cannot be a geometric sequence, because usually the format of a geometric sequence is AR, which is the common ratio, raised to the power n minus 1. And as we do not see any n minus 1 or exponential forms in this progression, we could easily conclude that this is an arithmetic sequence. What else is an arithmetic sequence? It is the nth term, a plus n minus 1d. And what is the formula for Sn, or the sum of nth terms for arithmetic sequence? It is 1 by 2. It is 1 by 2 n a plus l, which is also given in the formula booklet. Now the last term is actually the nth term, because the last term could be the nth number of term. If they would have asked for the sum of the first 4 terms, then the last term would have been basically your nth term, but with n substituted with the value 4. In this case, first n terms, so your nth last term is going to be the progression formula, the nth term formula. So we can substitute L over here with 1 by 2 n a plus p plus q n. But still this is not enough, because we need to find an expression that relates p, q, and n for Sn. There is a over here which we do not want in the formula. How do we get a? Well, we know a is the first term, and we know that this is arithmetic sequence, which is equals to a plus n minus 1d. So to get the first term, a, all we have to do is put 1 instead of n, because we're looking for the first term, and we get p plus q. And therefore, we can substitute it back into the sum of n terms, which will be 1 by 2 n p plus q plus p plus q n. We can simplify this. It will become 1 by 2 n 2p plus q plus q n. And that's your final answer. You can further simplify it or keep it in this form. Part 2. Given that S4, or the sum of first 4 terms, is 40 and sum of first 6 terms is 74, find the values of P and Q. Now it's obvious over here we're going to solve the simultaneous equation, because we're given two relations. So let's write down those relations first. We know the sum of the first 6 terms, S6, is 72. We can go back up to our original formula, which we had just made over here. We're going to substitute the value of 6 instead of n, and we're going to do the same thing in the brackets as well. Now we can simplify this. We could multiply 1 by 2 into 6 and take all of it and divide over here with 72. So we get 24 on this side, and we're left behind with 2p plus 7q. So let's make one of these variables a subject so that we could use it in the second equation, which we're going to make in a minute. So let's do 24 minus 2p over 7 and make q the subject. That's one formula done. Now let's go to the second equation, which is sum of the first 4 terms. That is 40. Do the same thing here. 4 instead of n. Similarly in the brackets. This should be q. Now let's rearrange. So when we will multiply 1 by 2 into 4 and then take all of it over here and divide with 40, we will get 20. And again we are left behind with 2p plus 5q. And for this one, let's substitute the value of q in this equation. Or let's make Q the subject over here as well. So over here Q becomes the subject as 20 minus 2p over 5. That's equals to Q. Now we can equate both of these equations. And now when we will solve for p, we will get 5. And we can substitute the value of p back into one of these original equations, any one, it doesn't really matter. And for q, we will get 2. And that's your answer. Question 9. Functions f and g are defined for x belongs to the set of real numbers by f x 1 by 2x minus 2 and g of x 4 plus x minus 1 by 2x square. Find the points of intersection of the graphs of fx, y is equals to fx, and y is equals to gx. So let's write these equations down. So what do we know? Y is equals to fx, that means y is equals to 1 by 2x minus 2. That's our first equation. The second, y is equals to gx. Y is equals to 4 plus x minus 1 by 2 x square. To find the points of intersection, you need to solve both of these equations simultaneously. So we can equate both of the y, and we can get 1 by 2 minus 1 by 2x minus 2 is equals to 4 plus x minus 1 by 2 x square. Now when we will rearrange, we will get 1 by 2 x square minus 1 by 2 x minus 6 is equals to 0. And now we can put these values in our calculator and solve it. 4, we can put in the formula, so a is 0.5, and then we have b as minus 0.5 and c as minus 6. And we get the values of x as 4 and minus 3. x1 is equals to 4 and x2 is equals to minus 3. You could solve this quadratically or by doing factorization, but make sure that you do not show that much working, as it's really just 3 marks. But on the safe side, it would be a good choice to do the working. y1 will be 0 and y2 will be minus 3.5 when you will substitute each of these x values back into the original equations. So from here we have found 2 points of intersections. The first one is 4, 0, and the second one is minus 3, minus 3.5. Find the set of values of x for which fx is greater than gx. We already had figured out in the first question that when we solve both of these simultaneously, we get this equation over here, 1 by 2x square minus 1 by 2x minus 6. So over here again, they're both equating them, but it's in an inequality. So we do not really need to show much working. We already know what is the equation we get out when we put both of them together. That is 1 by 2x square minus 1 by 2x minus 6 is greater than 0. And again, when we will solve for this, we'll get x1 is equals to 4 and x2 is equals to minus 3. Now, how do we find the range out of this? To do this, we could have a small sketch of what this graph looks like. So we know that the graph has a smiley face shape because the coefficient of x square is positive. Therefore, the shape of the graph will look something like this. And now they're asking for all of the values of x that are greater than 0 after rearranging all of the equation fx and gx. And we can see if you're going to find greater than 0, you need to look for values above 0. Over here in this area, the values will be negative, whereas in these regions and in these regions outside, we'll have the positive values. Therefore, we know that the points of intersection were 4 and minus 3 and 4. So all the values going more than 4 and all the values going lesser than minus 3 will satisfy this equation because they will give all positive values that will be greater than 0. And from here we can conclude that x should be greater than 4. Make sure to use the same symbol as it is used in the question, or you could use and, or x is lesser than minus 3. That's your answer. Part 3. Find an expression for fgx and deduce the range of fg. So it's a composite function. We can start by putting the function g into x, 1 by 2, 4 plus x minus 1 by 2 x square minus 2. When we simplify this, we get 2 plus 0.5x minus 0.25 x square minus 2. And after further simplifying, we get 0.5 x minus 0.25 x square. Now they're asking to deduce the range of fg. Fg over here is again a quadratic function. And to find the range is basically the set of y values which our graph occupies. So we can again sketch a graph for this. We know that the coefficient of x square is negative. Therefore, it will have shape like this, where all of the y values below some certain point will be part of the graph. And how do we know that certain point? You can calculate it in many ways. This certain point is also known as the turning point. And to find the turning point, you could adopt two of the methods. You could either do completing the square method, or you could simply differentiate. Both of these methods work for finding the y value. In my case, I did differentiation. So when we derive this equation, we get 0.5 minus 0.5x. And we know the turning point has a gradient of 0. 0.5 minus 0.5x. So when we solve for x, we get 1. But as I said, range is the set of y values. So we need to now get the corresponding y value for this x coordinate. So when we'll put this x coordinate in the original equation of the function fg, we will get 0.25. And therefore we can write the statement that fgx is lesser than, because again the graph is opening downwards, or equal to this symbol because it's the same symbol being used in the question, and because the turning point itself is also included in the graph, is lesser than or equal to 0.25. That's your answer. The function h is defined by h x 4 plus x minus 1 by 2 x square for x is greater than or equal to k. Find the smallest value of k for which h has an inverse. Now this question means that the function must be 1 to 1. As I had previously shown, the turning point is the point where the line of symmetry of our curve lies. If I resketch this graph over here, and suppose the turning point was here, the turning point acts as the line of symmetry. When we consider either of the halves of this parabola, the function is 1 to 1. But it is not 1 to 1 if you consider the whole quadratic function, because you'll get repeating values for one of x values. So for either one of the y values, you'll get 2x values, which we do not want for a function that has an inverse. We just want one y value for each x value. And therefore, they're asking us to find this smallest value of k. So this smallest value of k is the turning point, which we had actually calculated in the first question. But if you hadn't, you can also calculate it in the second method by adopting again different methods. We know that the x coordinate of the turning point can also be calculated through this formula where x is equals to minus b over 2a. This is really just a bit of the working showing how we could calculate the turning point in another way, because we have actually already calculated the turning point. So when you simplify this, you will get 1, and this is your smallest value of k. Question 10. The curve with equation y is equals to x cube minus 2x square plus 5x passes through the origin. Show that the curve has no stationary points. Whenever they're talking about stationary points, it's your first clue that you need to start deriving the equation and you need to get the derivative. So let us start by deriving this equation. We get 3x square minus 4x plus 5. Now they say to us, show that the curve has no stationary points. The derivative of this equation itself is a quadratic equation. And we know that the quadratic equation has real roots and imaginary roots. And the imaginary roots, we are not considering them as the stationary values. We are only considering real values as stationary points. And from this, we could apply the identity to find or prove actually how the curve has no stationary points. So for the curve to have no stationary points, the discriminant, why the discriminant? Because the derivative itself is a quadratic function. The discriminant of the derivative must be lesser than 0, which means it will have imaginary roots, which means it won't have any stationary points or no real stationary points. So we can write an inequality in this sense: b square minus 4ac is lesser than 0. When we substitute in the values, that is minus 4 square, minus 4, 3 and 5 is lesser than 0, we get our answer minus 44, that is lesser than 0. And this proves that the derivative had no stationary points. The stationary points could not be calculated from the derivative because they are imaginary, and the inequality is also proved. So just because you have found this proof over here, that's more than enough to score you the 3 marks, because you have proved that the graph has no stationary points. Now part 2. Denoting the gradient of the curve by m, find the value of m and determine its nature. Now this question might be confusing on the first glance, because in the first part they had asked us about the stationary points and proved that the graph has no stationary points. So how come in part 2 they're asking us to find some sort of stationary value of m? Well, of course you won't have this in the exam, but just for the sake of explanation, after graphing the original equation y is equals to x cube minus 2x square plus 5x, you will get a graph that will look something like this, with a slight bend, and then it continues upwards. Notice that the graph has an always positive gradient. It really has no turning point at all. So therefore, that is why the graph itself had no stationary point. M in this case is such a value that lies on the graph. And although it might be confusing because stationary value means that the gradient must be 0, then M itself should also be 0. This is not the case for the question. Whenever we face such a question where the wording does not make any sense, it's best to start from facts which we already know. The question said, denoting the gradient of the curve by M. What is the gradient of the curve? The gradient of the curve is given by its derivative. That means dy over dx is equals to m. And that means we can equate m with the equation which we made above, which is m is equals to 3x square minus 4x plus 5. And now they're saying find such a stationary value of m and determine its nature. A stationary value of m means we need to find a real value of m. We can equate this to 0 and bring m on the other side. 3x minus 4x plus 5 minus m. And now they're asking us to find a real value of m, because previously we had just proved that whatever gradient will be finding or turning point will be finding, it will be an imaginary number due to imaginary roots of the derivative. So to have a real value of m, we can say again from the discriminant that b square minus 4ac must be greater than or equals to 0. But in this case, we'll be taking equal to 0. Why? Because we need to find the minimum value of m. If we would have been asked to find the range of m, then we would have stated that b square minus 4ac is greater than or equal to 0. But we need to find a minimum value of m. And therefore, we're going to equate it equals to 0. We can again put in the values minus 4a and then c, which is 5 minus m in this case now, equal to 0. And now when we will solve for m, we will get 11 by 3. And now they're asking us determine its nature. So there are a couple of ways of determining the nature of this value m. First of all, we already know that the derivative is a quadratic. And if we sketch this, it would appear to be something like this. Why above the x-axis? Because again, it has no stationary points, and the stationary points are only found if there is some sort of intersection of the graph with the x-axis, which in this case there isn't. So this m value which we have found, how can we determine its nature? Well, we know that this m value is going to be such a turning point over here. How do we know? Because we just assumed such a value on the graph of the original equation. And this m value is none other than the actual turning point of our graph above. Dy over dx is equals to 3x square minus 4x plus 5. So how do we know its nature exactly? Well, according to the question, as I previously said, there are many ways. You could either do double derivative, take the second derivative, or you could simply just sketch the graph and show that the graph has this shape and it has one turning point that is its minimum point. So once you sketch the graph, you could then also write that it's a minimum value. You could also do the double derivative, the second derivative, and from there as well, you could identify whether it's a minimum value or a maximum value. In this case, it's a minimum value because our derivative graph has a turning point at the bottom, not at the top. Part 3. Showing all necessary working, find the area of the region enclosed by the curve, the x-axis, and the line x is equals to 6. Let's again have a rough sketch of how this might look like. Of course, you would not come to this kind of graph in the exam. So we could just suppose a typical kind of cubic graph. Suppose it's like this. We know that it passes through the origin, so let's just make it something like this. Or you could make it with a curve or the typical cubic graph. It really doesn't matter. So we have this cubic graph and they are saying the area of the region enclosed by the curve, the x-axis, and the line x is equals to 6. So let's suppose an imaginary line that is 6. And they're asking us now to find this area. The area of the graph which is enclosed between the x-axis or which is under the graph can be found through integration, where our maximum value will be 6 and the minimum value will be 0, because they said between the x-axis and the graph. How do we know that minimum value is 0? In the first question, if you notice, they said that the curve passes through the origin. So if it passes through the origin, it limits the area right at that point. So the graph, if they hadn't said that it passes through the origin, would have been something like this. Where in this case, we would have to also consider an extra area along with the area in the positive side. But that's not the case because the graph does pass through the origin. So the minimum value will be 0 and the maximum value will be 6. And we basically have to integrate our original equations and find the definite integral in order to find the area. So we can put our equation over here, x cube minus 2x square plus 5x, and we are integrating with respect to x. So when we integrate it, we get 1 over 4 x raised to the power 4 minus 2 over 3 into x raised to power 3 plus 5 over 2 into x square with the limits 6 and 0. And now you could either put this in your calculator or you could do the working over here. The working is done if you put the first bracket and you put the value of 6 and then you subtract it from the lower limit. So you could show the working or you could directly calculate the answer. The final answer will be 270. For those of you who are wondering, the working will be something like this, where you have 1 by 4 and you have the upper limit 6, 4 minus 2 by 3, 6 cubed plus 5 by 2, 6 squared minus the lower limit basically, which in this case will be 0. So we can just completely ignore it. All of the values will be 0 in the end. So you'll get the answer 270. And this was your paper May-June 2018 complete. Hope you understood it. Please like and subscribe, and I'll see you in the next video. Goodbye.